Okay. All right. Here we go. I guess the rules are I turns working live in class, although you can never really see that screen very well. All right. Let's just stick these words in here. We didn't really talk about. I have said this before that tangent is slope, but it's really not important for this connection. At this point, we need to know how to graph. And what I'm going to do is remind you of graphing, do add some components here. When you look at the homework, there's two different sets of homework. It's not long. Actually, most people almost walked out of here with, most of it done before the bell rang. But like I said, one homework is the graphing, two sides. Then another one is AP multiple choice question, which I wanted to wait for. Okay, so on the homework graphing side, I want you to do this again. Right at the top of each page is what does the parent look like? So it's smart to do that again. We know the parent, and this is specific. This is the graph here. That's pi over 2 there. That's located there. That's because the period for tan and cotan from Friday is pi over b. It's because. It's just that's what happens. So you got to figure that out. So what I did on Friday was I said these are always located at not the period, half. You got to go half right and left for tangent to draw the asymptote. So we have to have that knowledge in our head. So this one is negative half of whatever the period is. In this case, the period is pi. So that's why we see negative pi over 2 and pi over 2 at those positions. So just note to self, and then one more note to self, tangent increases. And this is where the A value goes. So that's A equals 1. So whatever A is, that's what it is. If there's a 3 there, it stretches, and so on and so forth. Half shrinks, blah, blah, blah. Whereas cotan, same rules, pi over B, except that is what that asymptote is. That's why tangent is easier. So it starts with an asymptote, maybe you scratch that in there, and then ends with an asymptote, the period's done. Then you can do another period, another period. Also, another reason why cotangent is easier to do two periods, you just cut and paste the negatives. It's easy. Two periods for tangent is not so much. So I need to keep adding a quarter of the period. Play along with yourselves here. 1 pi over 4, 2 pi over 4. All right, I need another period, so I have to keep going. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. We had one like that on Friday. Wasn't too bad, but that's what you have to do to create the second period. So that's another reason why I won't like tan as much, but that's okay. Then we're going to put some generalizations. Well, grab your highlighter. So it makes sense that this is why this is one of my asymptotes. It's right there. So the asymptote, we right in there? Good. Okay. Looks like he's coloring. And then notice that this is one period. The asymptotes define the period. So that is why we have this little tack on component. What's going on over there? You can't find your who? Highlighter. Bummer. So you're looking for other people's highlighters? Got it. Okay. So that's why this one is just pi k, because when I plug in 0, I get 0. When I plug in 1, I get 1. When I plug in -1 for k, I get this -1 pi. It's not rocket science. It's easy. Yip, yap, yip, yap. He's not going to help your grade by talking. All right. Blah, 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 blah. All right. Here we go. All right. Now let's go to the next page. I'm going to take care of the parent stuff first. Then we'll go back to the AP questions. Because what we're doing is kind of synthesizing the last 2 days of notes. Thursday was secant, cosecant. Friday was tan, cotan. The period for secant is 2 pi over b. So this is 2 pi over b, this position right here. Well, b in this, the parent function's 1, so I get 2 pi. Half of 2 pi is pi, pi over 2, 3 pi over 2. And then draw this. This is for the severely and totally. Where are they living, everyone, if they don't know how to graph cosine? No, farther. Pluto. We threw them outside the solar system. Well, they're still in the solar system, but they're not even on a planet anymore. They don't deserve Jupiter. What? All right. So you don't know how to graph that. I can't help you. I can't. All right. You're severely totally behind. You frustrate me. Again, just like he emailed me about what was Friday because I didn't put the calendar up. I put the stuff in the dumpster for everyone else to dumpster dive because it's trash to not do anything over the weekend and keep up with stuff. This is why we're always behind. All right. So, did I say good morning? Sorry, I felt like I went negative. You see some eyes. Rabid dogs out there. All right. So, and then what do we have at the zeros? What do we have at the zeros? Asymptotes. So that's why we have that one. You pick one. But then here's the problem. No, not a problem. This little tack on component, that just means each asymptote is half the period away. And actually, that's what that represents as well. But I haven't graphed that yet. So one of the asymptotes plus half the period away is the general rule. Don't be a robot, a formula maker. You know, when we have these AP questions, I'm going to leave you alone in your group, walk around, answer them, blah, blah, blah. But then I'm going to come back and explain them and do a quick sketch. And it doesn't take long. It doesn't. All right. And then this one here, what do you graph for cosecant over a period of 2 pi over b? You graph, anyone? What do you graph for cosecant? Sine. And then you should grab your, you know what I should have highlighted? You should grab your highlighter. That this is because I'm done. I'm done. I'm done with you guys saying this is hard and I don't get it and this and that. It's because of what you're creating for yourself. You create your own difficulties. You're the causer of your own demise by missing and not doing anything. So to graph secant and cosecant are nothing. It is not hard. I'm not going to let you say it. Oh, and then I did say this. Look at this. Here's this period. How many asymptotes do you count within that period? Why it's cracking up back there again. Forget. You see two. That's why they're half the period away. All right. And then how many asymptotes? Ooh, actually, this is tricky. How many asymptotes are there between one period? Well, three, but the one they start at the ends. So it is half the period. And why does this work? Again, when I plug in 0, I get x equals 0. Let me zoom back. X equals 0 right here. When I plug in 1, I get x equals 1. When I plug in -1, I get this one right here. This is why this generator is there. Now notice when they put where k is an integer. Remember, that's k, e, z. This says the same thing. Write that again underneath. If you're still bamboozled, we've written this probably 10 to 15 times in the notes the last 3 days. This is where I question someone saying, what does KEZ mean? You're in a different world. All right? You're doing something. It's not good, whatever it is. All right. Now do 1 and 2. I'll walk around. Let's go. See if we can discuss with your friends. AP. Oh, by the way, I told you to get your homework out. Also, we're going to pass the stapler around because the homework is those 2 sheets, you know, and they're not going to be that long. I just wanted to separate graphing with AP questions. They're not bad, the AP questions. I just didn't want you got to be solidified in the graphing before you can answer AP questions. Also, at the end of your notes, I'm going to talk about some of the homework questions that are challenge. One. Okay, so do 1 and 2 first. Make sure you're all good. I'll get to you in a minute. Ding dong. At. This other. What the heck? Yeah. Again. Pi over 1/3. It's 3 times 5. Excuse me. Period. Snuck up on me.
Are you going to example 4?
Okay, ready? All right, here we go. And then I'll give you some time for the back page. So go to this page if you. I didn't hear anyone flip though, so I think everyone was discussing this. So here we have it's give the vertical asymptotes all of yes, all of them. Good. But we know that's just a downshift, and then that's just a stretch of 2. Does that affect the asymptotes? Yes or no? No. I am still going to do a quick sketch of this because what I'm supposed to know is tan has a pi over period. And people keep screwing this up, and I actually did this in our notes Thursday or Friday. That means there's a 1/3 in front of x. How many people put pi over 3? It's mind numbing to me at this point. How do you not know the difference between that and this? That's pi over 3. How are we putting pi over 3 when there's a 3 on the bottom? It is beyond me, this fractional dysfunction. All right, and then I will actually do a quick sketch of this because this is what's supposed to happen. I'm supposed to go half the period, half the period. There is a down one shift. For these are for the people that are behind. How do I graph this actually? But then I'll get the answer from this. And then you go up to 1, 2, and down 2. Yeah, I wanted to make sure I didn't have a negative. Down 2. That's what those points would be. So that'd be at 1. This would be at -3. All right. So just anyway, that's how you do a quick sketch. You don't need to in this question, but I'm just making the point that it's got to be this one. Then make a change. That doesn't even make sense. K is a variable anyway. Somehow we just had a little typo there. That's an integer. K is an integer. Well, could we have there KEZ? There we go. There's another time we write that. Means the same thing. Okay. So you got it. And it's and then I just wanted to make a note to self. The period is 3 pi. So therefore, that's how far the asymptotes are away. All right, very simple idea. Okay, next one, vertical asymptotes. This one's a lot nicer because the period is pi over 2 pi. This happens. This happens. So therefore, I get 1/2. Well, for cotan, it's real simple. And I'm going to draw this way out just to help my space. Half, fourth, eighth. I'm just having fractions. I'm not teaching it anymore. 1/8, 2/8, 3/8. Here's a quick sketch of this. It's upside down and it goes up 5 and down 5 at those quarter values. That's all that 5 means. I have no up down shift, no phase shift. This is simple. All right, for the purpose of this question, I know the answer already. Cotan ends at the period. The asymptote does. So I already got what my answer is. It's letter B. Kx equals 1/2. To continue this graph, though, cotan's supposed to decrease, but it's flipped. So it actually looks like a tan graph, except for the asymptotes being in a different spot. So that'd be a quick sketch of it, and that would work. Okay, more time on these. I'll give you about a minute, maybe 2. Go to those and try to figure out the rules on that one. That's literally what one of your homework assignment questions are. Then I'll come around and get the homework after we're done with this sample plus going over a homework question.
Isn't it?
Dang it, what's that?
When you look at it, it's insignificant. I would have it. I go for it. But 2 divided by 2. Yes.
If I check the stock market, I heard it's gonna be a bloodbath today. Stock market's going down. And it says it's gonna be minus 500, it's only minus 3. Oh, the Nasdaq is going bad. Portillo's is up. Hey, let me come around and get your homework. I'll give you more time. Get your homeworks. Me two of them.
There you go.
Me two of them. That's yeah. I think this is like.
I didn't.
Gavin will email me. Gavin, when did I get it up there? 1 o'clock on Saturday?
I have no idea. I did it yesterday.
Okay. Gavin emailed me, then I got it up by Saturday.
Okay.
So you can just go and get it.
You can.
Right, Gavin? I think it was like Saturday at noon.
Yeah.
When they,
Gavin turned mine
this whole group, gotta be digital? Oh my God. This is getting disastrous. Disastrous.
Yes.
Disastrous.
Hey, Don.
All right. Here we go. Okay, so real fast, again, for review purposes, it's 2 pi over b. That's what secant's graph is. So that's pi. And then just real quick, give yourself space. That means pi's here. Half of that's pi over 2. Half of that's pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, because I do need values. And then what do I graph from 3 to -3? Sine or cosine, everyone? Sine or cosine? Cosine, and this is all I should have to graph, because where are the asymptotes? Where the whats are? Where the whats are? Zero. Heard someone say right away, it's pi where one of them are. No. Okay, it's actually at these. So this is the only one that represents one of the answers. By the way, right below this, let me cowboy baby. Yeehaw. Right underneath here, we should make a note to self. Here's all asymptotes. One of them plus half of the period away. And then NEZ. We're going to like those kind of ideas. So just throwing that in there. Okay, next one. And then a little homework question. Then I shut up for the day. Leave you alone. All right. Yes, I heard someone say, finally. Okay, so it's 2 pi over pi, which is 2. I'll do the same thing. I'll put it over here, though. Real fast graph. Here's 2. Half of 2 is 1. Half of 2 is a half. 3 halves. No pi. That happens. You know it. Okay, and then, all right, we got a bunch of stuff going on here. We got 2 high-low, up 4. Right, so I guess I don't really have a lot to do with this, but it's really just about what the asymptote is. I didn't even go this far as making a sketch of this. I think I ignored that, and I just I figured out where my asymptotes were. But so I got to move this because I'm committed. All right, or I should be committed. What? Anyway, anyone get that? Never mind. Okay, so over the whole class's head. Down to, back, and then up to, and then down. Where are my asymptotes? Here. That's all I did. Last hour, I didn't even do the up 4 and, use -2 as my A value to do that. So Which one represents what of the asymptotes? Looks like just x equals 1, right? Right? Okay, anyone get that? How many people got that? All right, good. Last but not least, and I forgot to do this. I said I was going to do it last hour, but I didn't. I don't even need to find the period, but I will. 2 pi over 1 half. 2 pi over 1 half is 4 pi. 4 pi, 2 pi, pi, 3 pi. And then cosecant, I graph a up 3, down 3. I graph another sine and then flip. Notice none of these I actually finished the picture. This one I will, to get you to understand that these are 3 and -3. Okay, I had to go down 3 and up 3 for those high and low points. So I'm making the point that this is not the range. That's the range if it was just sine. I have to flip all of those y values. That's the flip of those y values. Again, I almost forgot. If I had like a -2 on this, that means everything gets shifted down 2. So then that would be -infinity to -5. Union that with, sorry, that's a bracket 1 to infinity. Just playing around here. Just trying to get in your brain. If we got moved down 2, then the range gets moved down 2. And that should be able to be figured out without having to do the sketch. This should be like pictured in your mind. You don't even need 1 pi, 2 pi, 3 pi, 4 pi. Fumble. Okay, last but not least, look at your homework. Dang it. I just did the opposite of what I said I was going to do. Didn't I collect your homework? Okay, I just wanted to look at this one. So I screwed up. I meant to save it here. But here's what you saw in this key for this. Okay, look. Okay, this is just for your brain anyway, and you may have, I gotta set this in the background, otherwise it's gonna get all jacked up. Okay, you should think of this as this way, but then also you must pull out a half. Please watch. I'm really tired of this mistake over and over and over again all year long. What does pi over 2 become when I take out a half? Some people say it's pi over 4. Good foilers say it. Actually do it. What is half of pi over 4? Pi over, if you can't do that either, I'm going to be sad. Pi over 8. Does that say pi over 8? Yes or no? No. This is what good foilers, this is still not happening. I'm still getting major amount of people that cannot figure this out. You are a liar when you say good foilers say it. Liar, because you're not doing it. So therefore it's this, then you check. Okay, I've said this since August. Does that become pi over 2 when I throw it in? Yes. This is what good foilers, good factors means, you guys, and it's good distributors in this case. But anyway, it is getting rough. How many people still miss these things over and over and over again? And it's frustrating for me. This is pi right. Okay, so now that changes this. Vertical shift's no big deal. Oh, sorry, -1, so it's down 1. Here's the kicker. So I am going to phase shift on you. On your graphing worksheet, you do have to phase shift. Okay, so how would this graph look? I have a period of 2 pi. It's tangent, so I must cut the period in half. I'm not graphing yet. This is where the graph would be. This is where the asymptotes would be before the phase shift. But now I have to move all of these right. So that ends up right here. And then pi's asymptote ends up at 2 pi. And then really what you have, and that's why this phase shift was nice. It actually works well with the period. Phase shifts that don't are terrible, and it's really hard to do for the students. All right, and then to graph this wrong, we have a down 1. So I'd make that -1. That's that point. Oh, and it's not flipped. So I go up, wrong. I go down 3 from this and up 3 from this point. All right, kind of a skewed graph there, but that would be a quick picture of this phase shifted because the phase shift was so nice. So what is the equation of all the asymptotes? X equals 2 pi n. N E, what letter? Everyone say it. I don't get it. There's nothing to get. You do it. You just do it. Okay, and then this is y. I plug in 1, I get this. I plug in 0, I get this. I plug in -1, I get the next one way out here, which is -2 pi. You should understand why this is a thing at this point. All right? Okay, I'm done now. I'll stamp, and then we'll go from there. So phase shifting, when we keep it nice, should be easy. I have a phase shift on one of the graphs on one page. I have a phase shift on the other graph.